Hello students, in this class we shall study about some short questions and numericals on crystalline solids. Before I start, I will request you to subscribe to my channel, and now let us begin with these questions which are very interesting. See the number one question, very easy one. Why ionic solids are insulators in solid state but conductors of electricity in molten state? See, ionic solids, the main particles are ions, but in solid state these ions are held together by some strong forces. Due to these strong forces, these ions are not free to move. Not free to move. Hence, they are insulators, and electricity does not pass through. But in what happens in molten state? Molten state, or when they are dissolved in water or some solvent, dissolved in some solvent, what happens? The forces between the ions are not so strong, and the ions are free to move, and hence the electricity passes through the ionic solid in molten state, as the ions are free to move in molten state. Now let us come to the second question. This is second question. Why graphite is good conductor of electricity despite it being a covalent solid? Generally, covalent solids, they are insulators. They are not conductors of electricity. But graphite is a good conductor of electricity. So what is the reason? Graphite is good conductor of electricity. Why? Because see, in graphite, carbon has 4 valency electrons, and 3 valency electrons are, these 3 carbon atoms are attached to this central carbon atom in the same layer, but the 4th valency electron, this electron, it is, these 3 carbon atoms are in the same layer, but this valency electron is present, it is present between the layers, and this valency electron, it is free to move. As this is free to move, electron is free to move, then graphite becomes a good conductor. Good conductor. Clear? Now it makes, due to this free electron between the layers, it makes graphite good conductor of electricity. Now we come to the third question. How many atoms are there in a simple cubic unit cell, and what is its coordination number? See, in simple cubic structure, the atoms are present at 8 corners of cubes. See, cube has 8 corners, and at each corner there is one atom, and that atom is shared by 8 unit cells. See, unit cell is cubic in structure, and at the cubic structure 8 corners are there, and at the 8 corners there is one atom present, but each atom is shared by the adjoining unit cells. So 8 atoms, they are shared by 8 adjoining unit cells. So the effective number of atoms will be 8 into 1 by 8, and that will be 1 atom. So number of atoms in a simple cubic unit cell will be 1, effective number. And what is the coordination number? Coordination number is defined as the atom which is in contact, number of atoms in contact with the one atom of the unit cell. So in this there are 6, one atom is in contact with 6 spheres or atoms or particles of the unit cell. How? If this is the atom in the unit cell, then 4 atom, it will be in contact with 4 atoms in the same layer, one atom at the upper side and one at the lower side. Then in total there are 6 atoms in contact with this central atom, and we say that the coordination number of in simple cubic unit cell is 6. Now we come on to the 5th question, that is, how many atoms are there in body center cubic unit cell? Body center. In this structure, what happens? There are 8 atoms at the 8 corners of the cube, and effective number will be 8 into 1 by 8 is equal to 1. Effective number as happens in simple lattice, simple cubic structure. But beside this, there is one atom or one particle at the center of the cube, which is exclusively exclusively belong to that unit cell only. So it is one atom, and its effective number is 1, which are present 8 atoms which are present at the corners. So the total number of atoms will be that will be 1 plus 1 is equal to 2. So the answer to this, how many atoms are there in body centered cubic unit cell, it is 2. And what is its coordination number? See, in coordination number, the body centered cubic, the coordination number is 8, means the one particle or one atom is in contact with 8 other atoms. So the coordination number is 8. Now we come on to the next question, how many atoms are there in a face centered cubic cell. In face-centered cubic cell, 8 atoms at corners, at 8 corners of cube. This is there. 8 effective number will be 8 into 1 by 8 is to 1 atom. But beside this, plus 6 atoms at each face of the cube, and these 6 atoms, all the 6 atoms are shared by 2 unit cells, so its effective number will be 6 into 1 by 2, that is 3 atoms. So the total number of atoms in face-centered cubic cell will be 1 atom plus 3 atoms. 1 plus 3 is equal to 4 atoms. This is the total number of atoms in FCC unit cell, and its coordination number is 12. We say that each atom or each particle in FCC structure is in contact with 12 atoms, hence the coordination number of FCC is 12.